All right, so a few of the topics we'll split this about half and half, but basically we'll look at how you can perform and obtain some pedestrian measures of effectiveness through using Vistro's signalized intersection analysis from the Highway Capacity Manual 6th edition method. And then we'll look at the bicycle analysis measures that are available as well. And then the last part of my session will be honing in on how some of the interplays between the modal interactions and how, while there's not necessarily a transit measure of effectiveness in the Highway Capacity Manual at the intersection, there are ways that transit service does affect the operations of the intersection as a whole, and how you can utilize some of that information when you're analyzing existing conditions or looking for modifications perhaps to your locations of bus stops and so forth. All right, so just quickly, if you look at the red box here, is kind of the short story of this slide, but basically a lot of people don't know, even those who have been doing a lot of analysis for a number of years, that the Highway Capacity Manual has at the intersection level for signals some performance measures that you can calculate and report. These are the 5 in these bullets: a corner circulation area, a crosswalk circulation area, the pedestrian delay, and then also a perception score for how well the pedestrians perceive their quality of service at the intersection, and then a level of service grade based on that perception score. That was part of the multimodal research that went into the Highway Capacity Manual a few years ago. And this particular screenshot here is a schematic of all of the different inputs that we will then have as part of the input into Vistro in order to calculate and obtain those measures of effectiveness. So with that, let's switch back over to Vistro. I have an intersection here that is in a suburban downtown, if you will. That might sound like a contradiction in terms, but it's California City with a lot of pedestrian and bicycle activity and transit lines running, but it's not an urban core. And this is a good intersection to illustrate some of these HCM methods from that perspective. What I do want to highlight here is just so we can remember where we are on our pedestrian inputs, because we'll talk about those first. You've seen, hopefully, or attended our previous sessions on how to build your intersections and how to use the base mapping. I've just gone in and, just for the sake of having things a little bit easier to see, I'm going to highlight this background intersection schematic so we can remember where we are as we enter our data in Vistro. All right, so with that, in the intersection setup table, which would be the one that I would have coded my intersection in the first place for lane stripings and lane widths and so forth, there are a number of entry fields that are needed in order to analyze the pedestrian measures. And these are, again, an intersection setup. And if you scroll down here, you will get to a part where it says W sub A, walkway width of sidewalk A, and then sidewalk B, radius, crosswalk, checkboxes, crosswalk widths, and lengths. And so just as a quick, I know this is kind of just data entry, but just so you guys are aware of where those entry points are, if we look at this intersection, probably typical to your workflows, there would be a few things that you can do. One would be, after you draw the intersection in Vistro, to utilize our Control A wireframe mode to go in and be able to do things like using our measurement tool to be able to measure, crosswalk length, for instance, and so forth, that you can do directly within Vistro. And depending on your part of the world and the underlying quality of the Bing imagery, that may be sufficient or not. What I found here were certain sidewalk widths that I would need in order to enter and so forth. It was a little bit tough to do it directly from the Bing image in Vistro. So like many of you, what I ended up doing was using a couple other tools. And just to quickly show that, obviously Google Earth is available, which has a nice measuring tool. I can zoom in and I can do things like obtain this sidewalk width You know, this sidewalk width here, crosswalk lengths, all of these are inputs to the pedestrian methods. And then also what's just to orient ourselves and make this a little bit more realistic, we could also, of course, look at a street view look, and you can see some pedestrian activity, like I say, suburban location. We do have bike lane stripes, which we'll talk about in a little bit when we talk about bicycle analysis, some on-street parking on some of the corners. But I do want to highlight one of the nice things to identify for this as a study intersection is there is a kind of a local amphitheater here. Well, not amphitheater, a local auditorium, if you will. Seats maybe 2,000 people, something in that nature. So this intersection will have some times of day where there are events that are going on here that would contribute to additional pedestrian activity. So this just orients us a little bit to the real world location. Essentially then, as part of these measures that we can obtain for pedestrian analysis, all of these types of data are required to enter. So while a little bit specific and it takes a little while to go through, essentially walkway widths A and B, if we look at the schematic from the highway capacity manual, essentially if we look here, the B walkway, this is a southbound approach like this, would be the width that we would have on this portion of the intersection, and then the A would be after you round the corner. And the reason those are important, it has to do with how much width there is for the pedestrians approaching and a holding area waiting to cross, but also the movement of the pedestrians as they turn the corner, even if they don't utilize the crosswalks at the signal, and that there's measures for that. And so while that can be interesting at any intersection, ones like this where we do have this auditorium and the parking garage for the auditorium right next door, there will be during auditorium events, there will be times where there's quite a bit of activity pedestrian-wise rounding this part as they come from the driveway or from the parking garage and round the corner to go into the entrance of the auditorium. So again, just kind of highlighting how this can be useful in real life conditions. And so from there, I won't go through the individual measurements or so forth, but so that you get an idea and a context for why doing a pedestrian analysis can be useful in Vistro, that it would be those type of inputs for the sidewalk widths on all four corners, as well as the radius of the curb, and then presence of crosswalk and what those crosswalk widths are. Because remember, our measures of effectiveness will include all of that information in order to get us our results. So in Vistro, for pedestrians, on the intersection setup tab is where you would enter the specific measurement type data. And then after that, for pedestrians, you also need to go to the volume table. And here we will not only have all of our vehicular volumes and so forth, but there's a series of volumes specific to pedestrians. So outbound pedestrian volumes crossing. Let's make this a little bit wider so we can see. Crossing the different street segments. So we have outbound and inbound, and those all relate to this graphic here in terms of crossing side crosswalk using crosswalk C or D, and whether they're outbound or inbound with respect to the particular corner that we're looking at. And so here, as you enter these volumes, some of them will auto-populate because they will be similar. For instance, an outbound pedestrian along this crosswalk from this corner will be an inbound pedestrian on the opposite side of the street, and those will auto-populate as you enter them. And then ultimately in Vistro on the traffic control table, after you've had all of your other signal timing and so forth, like we've done in the other sessions, if you scroll all the way down to the bottom, you will see not only your delays and level of service and queuing and so forth for vehicles, but there's a subtable called other modes. And here are where you begin to see your results for pedestrians. So for instance, the corner circulation area, crosswalk circulation area, pedestrians delay, their score from the perception, and their crosswalk level of service. And so in this particular case, of course, you can do any of these just for existing conditions. I just looked here also using our scenario manager, built everything in the base case like we've done in the past, and then you utilized existing PM timings and volumes, and then created a duplicate of that scenario to call the existing PM with event. And essentially the differences between these two scenarios are looking at an evening peak where there's also an event that's going to occur at this auditorium. And of course, we would expect the vehicular volumes to increase a bit, and also the pedestrian volumes as well. So not to go through them all in detail, but these are reflective now of additional volumes for some of the turning movements for the vehicles to access the garage, but also for the pedestrians that are using other surface street or parking lots and crossing, so that we can utilize our scenario manager to do a with and without event comparison. So that's a bit of going over some of the measures that you can obtain for pedestrians. And then if we go back, oops, sorry, let's hold off on that one. Just to highlight again the different areas in Vistro where you have your inputs and calculations. Moving along to bicycles, let's go ahead and look here. For bicycle measurements, in the highway capacity manual, there are 3 performance measures for bicycles at signalized intersections. One is a bicycle delay, and then also a bicycle perception score, and the level of service grade that's related to that perception score, again, from the quality of service research that went in the last number of years to the highway capacity manual, is where those are obtained from. So if we go back to Vistro, we can go back to our intersection, we'll see, again, the same exact setup. The issue would be clearly as you're coding things, there's some inputs on the intersection setup table that are required in order to do the bicycle analysis. So these include the curb to curb width of the cross street, because that's part of it. How far does a bicyclist, say traveling northbound, have to traverse in terms of the cross-sectional width of the east-west roadway, as well as width of the bike lane if there is a bike lane, or a width of an outside shoulder if there's not a bike lane. So in this particular location, we do have bike lanes in the, sorry, the way you pan is differently in Vistro and in Google. Northbound has a bike lane that continues through the intersection and is adjacent to this on-street parking, and southbound has a bike lane as well. But east and west, there are no room for bikes. We see a bicyclist, they're sharing the lane with the through traffic. And here you can see there's not any extra outside shoulder, but you may have an intersection where it's not striped as a bike lane. However, it is wide enough that bicyclists kind of use it and have an extra buffer from the adjacent vehicles. And if that's the case, then if you don't have an actual striped bike lane, you could enter the width of the outside paved shoulder that would allow for bicyclists to utilize that space and then receive some positive benefits on the measures of effectiveness calculations. But otherwise, there's other inputs in terms of whether or not there's a curb on the approach, and also if there's on-street parking, how wide the parking lane is, and what percentage of it is occupied. So basically thinking about the physical constraints and also the parking activities and how those are input and affect your bicycle operations. And so in this case, we did have on-street parking. Everything's on the approach here. So on-street parking on the southbound approach and on the westbound approach, and it's pretty heavily utilized and different widths and so forth. From a volume perspective, the only thing that needs to be entered is a bicycle approach volume for each approach. And then under the traffic control table, again, all the way down at the bottom where we have the results after the vehicle results, then we have the other mode results. And then there's some that are specifically related to bicycles. So saturation flow rate, capacity, which is just sat flow times G over C, and then your bicycle delays and the quality of service score, and then the resulting bike LOS. And so again, you could do that for any existing condition and then any with project, whatever it might be. It might be with an event, it might be with a new project, being new development occurring, things of that nature. But all of these, just like the things we've shown you before, utilizing our integrated scenario management tool helps you to be able to account for those MOEs under different conditions, different peak hours, if nothing else. So that's kind of the bike and PED quick tour of the different measures of effectiveness that you can obtain from Vistro. On the transit side, again, there's not a transit method at the intersection level to get an MOE in the HCM, but there are sat flow adjustments many of you are probably aware of, bus blocking factor, for instance. And let's just take a quick look at what that means for your intersection setup. Basically, back here again, I can see as I pan around, I have a bus stop location here on the far side of the southbound, and it's a little bit harder to see, but there is a cutout right in this area of a bus stop on the far side northbound, and there's a couple different lines that run on that roadway. There are no buses east-west, so simply in Vistro, I just make sure under intersection under intersection setup that I account for that there's some bus information, and under the volume, sorry, that's really where most of it is, I think, for the heavy vehicles, for the buses. But we have a bus stopping rate, how many buses per hour. So northbound and southbound, I have about 12 buses per hour stopping, and with that information, that will affect our vehicular saturation flow rate for buses. Now, even all the things that we did for bikes and PEDs earlier I showed you were to get measures specifically for the bikes and PEDs, because those are the things that I think a lot of folks don't realize you can obtain through using Vistro's HCM implementation. But of course, the bikes and PED also have an interplay intermodal interaction with the vehicles, and that has been in the HCM analysis for years. And so there's also some additional things that Vistro does to account for those in the saturation flow, of course, for the left turn and right turn effects of PEDs and bikes on vehicular saturation flow rate. And then the last thing I wanted to make you aware of is, in Vistro, we have a number of different methods that are available to you. Primarily, I'd say probably most predominantly, everybody's using the highway capacity manual. However, at any of these, either globally or at each signal, you can choose between the different HCMs or some other planning level. But also, we have the Canadian Capacity Guide 3rd edition that we implemented a couple years ago, and are making a push with CITE to help make people aware that method is available in our software. If you were to use the CCG method in our software, there are some additional considerations. In CCG, it splits out the effects of both near side or far side. HCM, it really just looks at, like, are you within 250 feet of the signal? And in both of those cases, north and south, we were. But here in the CCG method, it would also take into account dwell time and percent loading on green, and it would identify whether that's near side or far side. And on the far side stops, it also looks at how much space is available, because of course, if you're on the far side operationally, that's supposed to allow for better traffic flow for the rest of the vehicle movements. But if there's not sufficient space available, you'll still get queuing back into your signal. So I'm not going to go into details on the CCG, but I did want you to be aware that there are other inputs and ways that you can account for, and even if you're looking at location planning for where to place your bus stops and how it affects intersection operations, it may be worth the quick toggle over to the CCG or a method within Vistro in order to see what the differences are.
So first, I'm going to start talking about the parallel cycle track topic of this session. But before I start, I'm going to go through these examples pretty quickly if you're unfamiliar with how to use sync with Vistro right now. But there is a learning center area that we have with PTV Vistro, and I've made a blog article on this. And so if you type in PTV Vistro Transit Planning Tool, you should get this result for this Future Learning Center for Active Transportation and Transit Planning. And if you click on that link, there will be 3 YouTube videos explaining pretty much everything I'm going through, and it will list all the steps that you need to follow to recreate what I'm doing. All right, so reasons to add a parallel cycle track. And if I zoom in, you can kind of see that there's this one skinny lane next to the main roadway. The reasons to show this is because you can create a time-space diagram along this facility using our route tool. And this looks like this, where this is the mainline route. And then you can also have a bike route along the facility. And by having this bike route along the facility, you can kind of see that there's the progression potentially for bicyclists based on the speed that the bicyclist is actually going. Because the mainline route, this is based on auto speed, and then on the parallel facility, that would be based on a bike speed. And you can see how the time-space diagram is a little bit less sloped, and that reflects the difference in speed. The other reason why you could do a parallel facility like this is so you can create a specific bike phase for the cycle track, and then you can reflect that specific bike phase in your signal timing. And if you're going over to VISM or something like that, this bike phase would also come into VISM, and it just jump starts that process. However, there's one thing I want to note before I get into the details here, is you don't want to optimize the cycle track along the route. That's not recommended. And there's a few reasons for this. One is that the optimization for that route would require some sort of volume. And in Vistro, the volume is cars and trucks, not bikes. And so you have those nuances of these vehicles aren't going to be forming diamonds when they queue or be as close together, and the vehicle lengths would be longer than what a bicycle vehicle length would be. So you would get some results that probably you wouldn't want if you tried to optimize the cycle. Optimize the cycle track. So one thing you can do, however, is again view the bicycle route, and then you can manually drag the bicycle facility to get better optimization. Because who finds that more frustrating than cyclists than to have to stop every signal and not be able to actually get through an intersection on their bicycles? Okay. So how do you start a cycle track facility? Well, let's open up this example here. So give me 1 second. And it's probably asking me if I want to save somewhere. Oops, where is that screen at? Uh-oh. Here, I'll just open a new one maybe. I have too many windows open. I can't find my Save As button. Give me 1 second. Okay, so here's my new Vistro. I'm going to open up the example. Come on. Oh, it's doing this because I have a dialog open. There we go. There it goes. Sorry about that. All right, so I took the the full example of what I just showed, and I kind of simplified it a little bit to just 2 intersections, and I'll show you how to build that cycle track along the facility. And so the first step you need is a connector, something like this, that would fit between the intersections. And why you would need a connector is because you already have a leg connection with the main line. And so Vistro can only allow one connection between the 2 intersections here. So you need to have a separate connector to tell Vistro that that's okay. And to create this connector, what you can do is go to maybe a 2-way stop control, make an intersection, and the quickest way to do it is just turn the first 3 approaches into only a through lane. And then you can delete the 4th approach here, the lane configuration. And what that does is you start to be able to create the connector. On this left side, then you would remove the through lane, and you can see now I have a straight through here. And then you can delete the 2 legs. And then you have something like this. And then finally, you can just take out the crosswalks on the connector, and then change the speed of that connector to something that might be a bike speed. Maybe it's about 12 miles per hour would be a decent bike speed. And then lastly, you can change the lane width of that connector to maybe 6 feet. And so now you can see I created a connector. And once you have this, you can copy the intersection. You just right-click on the main node or hit Control-C and Control-V, and then you can paste it. So you don't have to recreate that every time. But I already have one. It's already created. And the next step would be to add additional legs to the intersection, so you can have the facility go through the intersection. And you right-click again on the main node and you hit Add Leg. And it will create 1 leg, and let's make that the inbound direction. And you hit the Add Leg again. And then you will create the outbound direction. However, right now we don't have the receiving lane going outbound, but we'll fix that in a second. And then let's do this for the other intersection. We'll hit the Add Leg. I'm going to move this guy out of the way so I don't accidentally snap on that. Okay. And I'm exaggerating right now the legs. It just makes it easier to organize which leg is which when you connect all of these up and edit the data. So let's go back to the first intersection. I know it's this one right here. This is the receiving leg. I'm going to hit the show name and call it bike, just so I know which one it is. And then I'm going to do that again with the eastbound here, and whoops, call this one bike, so I know what it is. Turn that back on. So I know these 2 are the bike connections. And so what I need to do is, right now there's a turn basically for everything in this intersection right now. There's one to go through, there's one to turn right a couple times. And really all I would need to do is to make this right turn, which will become a through in a second, but this right turn to this receiving side. And you can click on the lane configurations for that, expand the window. You get a lot when you start adding legs. And then delete this one because we don't need it by hitting the minus. And then I can select the right turn, which is, if I can find it, looks like this one. And if I hit the plus and hit OK, nope. See, that went to the wrong side. So that was not the right turn. So that's a good indication to see if you selected the correct lane or not. So the right one would be potentially this one here. Nope, looked like that was the other one. I had this right before in my training. That's one of these. Let's try it one more time. Okay, so it's apparently not going to work for me right now. Let's try this one and just see if we can get it right. Okay, so this is the other side. Yep. So this one does have a right. This is what I was trying to get before. And if you click OK, you can see that this lane comes on this side right here. And that's exactly what I wanted. Now that you have this lane on the other side, then you can delete this lane configuration right here. And then you'll have the inbound and the outbound created. Now let's try to see what's going on with this one. Maybe I just put the leg in the wrong place. Let's try it one more time. This one is not liking me today. Okay, we're gonna move on, but that did do that the last few times I tried this example. And so now that you have these legs here, you can then connect up the connector. I'm just going to put it into here for now because it makes it easier. You can connect up the connector here and then add a spline point at each end. And the reason why I'm adding a spline point at each end is because it helps the approach offset be set. And so then you can set the approach offset. That is this row right here called approach offset. And what that does, that actually will say how far it offsets from the center line of the roadway. And I've written down on mine what the offsets would be, just so we could go through the example a little bit quicker. So this one's 18 feet, and then the other one will be negative 26 feet. And I'll fix these in a second, and it will look very nice. And at this intersection, we have 28 feet. And then we have a negative 16 feet. Okay. And then so once we got these into place and we have an offset put in, we can then draw our parallel facility. And you can pay a lot of attention to this or just a little bit of attention to this. It's up to you. And then you can see right here, I need to change the lane width, and we'll get to that in a second as well, and then the speed. Okay. And if you start getting some funky geometries in here, you can always change the offset a little bit, or, oops, I disconnected the connector. Change the offsets a little bit, whatever you need to do to get it to fit. So now let's change the widths and then the speeds for each one of these connectors. And so if we go look at the speed, the new one here, we can change that to 12. And then we can change the width of the lane up here to 6 and 6. There we go. And at this intersection, we can do the same thing where we can change the speeds to 12, and then the size of the lane we can change to 6. And then you can see how our parallel connector will change. And then to add the route, you go to the route button, and you can click on one end of the parallel facility to the other end of the parallel facility. Oops. It's not letting me click that right there right now. It's because I didn't assign that turn. That is why I'm still having problems with this turn. But it would, if you had the turn assigned correctly, you could go from one end to the other end of the parallel facility. And to add the signal group, you click on the main intersection, and you then go to the traffic control tab. And you can see that right now it's phase 2 and 8 for this intersection. Those are the main vehicle phases. And we need to add a signal group for the bike phase. And what we can do is go to the signal groups window up here. It's the plus button. And then we can click the big plus and add a row for a new signal group. And let's just call this 10 for simplicity. And you look at the signal timing down here. I have 33 seconds for the whole split. So if I go down to the split, I can say it's 33. Whoops, not 303, 33. And the max green would then be 29. There we go. And then I can take out the walk and pedestrian phases because it's a bicycle signal, and change it to a maximum recall. And then what that does is create that signal phase to be accessible into the sequence. And I can add it under 2 in the second ring. And it's a light green color because right now it's not assigned to the movement. And so I look for that movement where the bicycle lane is, and then I can add 10. And you can see that now it becomes a solid green color and the bicycle movement is put here. All right. So when it's all said and done, when you actually get it to work, I'm going to go back to the other example. And again, I'm not really quite sure what happened at this intersection. You can see in here, I could assign that turn just fine, doing the same thing. And then I get the route. I would assign the route through the one end to the other end for the bike lane. That's the part we missed. Actually, we're gonna just talk quickly about passive TSP phasing. So for passive TSP phasing, it's basically just like a hold phase that you might use that's on a recall, and it constantly is called up every cycle length. And the reason why you might want to estimate a passive TSP phase in Vistro is because maybe you have so many buses that would go through the intersection at every cycle length that you're always going to have TSP be called. So you can estimate it with a passive phase, or maybe the fact that you actually have a passive phase and then the transit is always called every cycle length. To put this into Vistro, again, you just click on the intersection and go to the traffic control tab. I already have it in here as in the sequence as 60, and then I put a barrier in. And so this represents that hold phase for a passive configuration. To create this, you would just go to the signal groups tab and then drop in a phase 60, similar to how I just did the bike signal. And then because it's the light green color, it is indicating that it's not part of a movement right now, which is okay, and it's just showing that it's a hold phase within this sequence. And then for an active TSP signal, it's the same example. I added a queue jump lane using the same methodology that I explained in developing the parallel cycle track, but this time I'm utilizing it more for a bus lane. And I can take that same signal group 60, but then actually make it part of this bus lane's movement. And so that's why it's a darker green color this time than as opposed to last time, is because it's now part of this movement. And when you do that, now that it's an active TSP, you would assume that it would have some sort of a detector to that lane. So every time a bus would come over that lane, the system would be called and then run that phase. So I did add a detector here, but the other phases I left as a max recall or a min recall. And then I could change this actuation type to a fully actuated signal in this case. That way the detection would work. But one caveat to an active TSP analysis in Vistro is that it's just an estimate, really. It's something that you can use really quickly to figure out, do I have this intersection sized correctly? Are my lane configurations correct? What are the interactions with a bus, with the vehicles, and the volume at this intersection? For the full TSP functionality and for results that you may actually need to report in some sort of documentation, you most certainly would want to use something like Vism to analyze this in further detail. And then with Vism, you can use the phase emit functionality and phase truncation elements, as well as any extension that you might need for TSP. One benefit of doing this in Vistro, again, is it brings over that signal phase, it brings over the detector and the lane, so that way those elements are already going into Vism when you start that deeper micro simulation. But again, it's just a good estimate and something that that you can use just for some knowledge. Okay. Now going into lead pedestrian interval, I'm gonna drop that intersection in here. We have an example in our help folder. If you go to help, open example directory, there's a pedestrian folder in there where you can see this lead pedestrian interval. And let's dig into this. I'm gonna click on the intersection so we can see the traffic control tab. The first thing you see that's different than from the other things I showed is that we have this red indication at the beginning of the phase. Okay, and so what this is doing, this is delaying the start of the vehicle green, and it's allowing the pedestrian phase to start first. So it's the leading pedestrian interval for the signal. And to be able to do this red, all you need to do, it's quite simple, is to look at this delayed vehicle green column in Vistro and just enter a value. Right now I have it set for 5 on both approaches. If we set it for something like maybe 8, you can see that this red blockage gets a little bit bigger. Okay, but I'm gonna leave it how it is right now. And the advantage of having this is that you don't have to code any hold phase or dummy phase that you may have to do in other software. You can do this all within this traffic control tab and keep it within the phasing that you would have out in the field. And it's pretty simplistic to just hit this delay vehicle green. And this also impacts the calculation. for that movement. The delayed vehicle green, this 5 seconds will be subtracted from the effective green time that's used for the calculations of level of service and capacity and all that stuff. This value does actually go to Vism, and so I have an example already preloaded here, and I'll just play it really slowly. This shows the leading pedestrian interval for the 5 seconds before the main vehicle phase goes, and you can see how it lets some of those pedestrians go early, and then it's more visible for the turning traffic when it turns green. There we go. Oop, it paused on me. There he goes. Okay. And so our last example, we're going to talk about exclusive pedestrian intervals. And so again, in the help folder, there is a mid-block crossing example that we have. I'm going to open that up. Yeah, so right here, it's under, again, go under the example directory under the pedestrians, and then you'll see this mid-block crossing example. And this is a perfect opportunity to use this exclusive pedestrian type of feature within Vistro. And what this means is that all pedestrians will go at the same time on all corners. If you had like a 4-legged intersection, they could all go at the same time. But in a mid-block intersection, you just use this feature and it will give you the capability to have everyone go at the same time without even coding this extra leg here. So I have, this is what it would look like if you didn't have this feature. And if you go to signalized with ped exclusive scenario in the example, you can see how to utilize this exclusive pedestrian phase. You scroll down to this area within the traffic control tab called exclusive pedestrian phase, and then you type in a phase number, any one that you would want to use, and then you would just type in the pedestrian walk and pedestrian clearance intervals for the crossing, and then just add it to the sequence once you have a phase identified. And you can see in this case it's phase 4. And then this is the exclusive phase for the pedestrian crossing. And as you notice here, the crossing bars for the pedestrians are not visible in the phase diagram. That's because everyone is going to cross during this exclusive phase. And if you look at the pedestrian intervals within the phasing and timing, they're grayed out, again, because they're not needed, because you specified an exclusive pedestrian phase. Okay. So we're going to hand it back over for questions.
Sounds good. Thanks, Adam, for that. We have just a couple minutes left. Most recent question just popped in, actually. When you talk about the PED phasing, the question says, how about 2-stage crossing, mid-block or at an intersection, but when there might be a pedestrian refuge, I am assuming it's the 2 stages they're speaking of. Do you have any thoughts on considerations for that?
Well, I mean, Vistro is pretty flexible, as you saw with the parallel facility. You could actually just code 2 links and have 2 separate pedestrian intervals there on the 2 links. That could be one way to do it. Vism does things a little bit differently. If you actually have a median specified, it will automatically give you the 2-stage crossing unless you tell it not to. So on the Vism side of things, you'll get the 2-stage crossings. On the Vistro side of things, one way around that would be, if you had a super wide median or something, is to just code 2 links and 1 in each direction, and then that way you'll have some additional flexibility.
Okay, great. So I know you mentioned the resources page. I'm just gonna put the link to that in the chat box. We'll also put it on the website afterwards when you get the info from us. But that also goes through some of or a lot of what we've covered today, including some more specifics. I'm just placing that there now. Otherwise, Adam, a question that came in as you were doing the cycle tracks, it appears that that example is a directional cycle track, and the question is there a way we could model two-directional cycle track?
Yeah, I haven't actually tested that myself, but as you saw when I was creating the one, you could have basically a leg with two directions on it. You would just have to be savvy enough to make sure those turn arrows went to the correct street when you did that. So that is a possibility to have two directions, and then you could assign potentially the two additional bike phases, one in each direction at the intersection. I could probably test that a little bit further. It sounds like a good opportunity to investigate.
Great. And then last one, thanks everyone for continuing to submit your questions. If there's any that we don't speak to live here as we run out of time, we'll be sure to follow up with you directly. The question talking about the TSP analysis, will there be, it says TSP design in Vistro looks like improvisation. Will you likely have anything that will be built into the software? Maybe you could just reiterate kind of the level of analysis and purpose for that. And also I'd refer back to the resource page that you had.
Right, so again, the TSP is more for like a planning level assessment where you can just take it and do quick screening analyses and just see like what would work before you get to the VISM stage. Because when you get to VISM, you kind of want to have an idea of what you want to do when you start going through the motions there. But yeah, it will get the signal functionality set up for you, so when you get to VISM, you can analyze a lot more in depth in that area.